Hi, everyone. My name is Michael Staib. I'm the author of the Hot Chocolate GraphQL library in .NET called Hot Chocolate. And I'm also a member of the GraphQL Technical Steering Committee, the body that is behind the evolution of the GraphQL specification. And at the moment, I'm working within the GraphQL Foundation on a new specification for distributed GraphQL. So before we dive into what distributed GraphQL is and what you can do with it or why you should even care, let's talk a bit about GraphQL, why GraphQL is so good. So back when GraphQL came out, and that is like in 2016, like GraphQL is already around since 2012 for people who don't know it. But in 2016 was the point where Facebook essentially open sourced GraphQL. And people were like very amazed about how GraphQL changes the flow that you have in building applications. Especially front-end engineers were starting to push their back-end engineers to introduce GraphQL to their specification. Because with GraphQL, we no longer think about response or request patterns or what requests you need in a backend to build your front end. We are rather thinking about data. And what that means is that GraphQL essentially has one very specific aspect in its query language, which is called a fragment. And a fragment in GraphQL is essentially the primitive for composition. Sounds complex, but it is actually a way to specify for your UI components the data contract. So in this example, for instance, we can see that the ticker component uses a fragment here, which is called ticker entry. This ticker entry contract describes basically the data contract for one component in our UI. But there's nothing about how to fetch this data, right? There's nothing about how to get this data transport-wise or whatever. If we did the same with REST, we would probably have a call there to fetch the data and then maybe massage it a bit and put it in our component. But with GraphQL, I just specify what data I really need, and then it's resolved somehow. So how that works is actually that when we build our components, our UI components, we co-locate the data contract, so our fragment up here. So we specify what this component needs for data, and then we use the data down there in our visualization part. The same thing works in Blazor if you're more into Blazor, but this is here a React component which uses Relay. So by building our application, by putting our components together, stacking them like little Lego blocks together, we're accidentally building a GraphQL request, a GraphQL query. Let me show you that with the actual application. So that is the actual application I'm referring to in my slides. And if I run that, you can see Wi-Fi. You can see that this component actually just has a single request to my backend. Although I have like a ton of components here on my page. Like I have this ticker here, I have here graphs, I have a couple of lists here, but it's a single request that I do to my backend. If I look into that, you can see then we have here this query where we have a lot of these fragments. Like this is built by building my application. So accidentally, we came up with this GraphQL query. And this works because in GraphQL, we have this unified API, this unified schema in which we reason about types rather than exposing certain requests, right? We're basically modeling an interface to our core business domain. And this allows us to build a much richer backend for our front-end engineers. And that works because GraphQL is a monolith. And that's also why front-end engineers love GraphQL, because they have this single schema where they can pick and choose data from that they want to use in their components. It's strongly typed. And I just have to go to this one thing to get everything. And when Facebook started with GraphQL, they built GraphQL as a thin layer over their business layer. That's how GraphQL started. So Facebook actually had a monolith running for 500 million users. And they just had this thin layer to expose the business layer in a much richer way to their front-end engineers. And suddenly we could build for different application types, device types, experiences without doing compromises or creating hundreds of specified requests in our REST or gRPC endpoints. But there are also problems to that, right? We have a monolith and we maybe have a ton of teams around that are working on this monolith. And when I worked back then, when GraphQL actually came out, at a Swiss insurance company, we were quite happy with the monolith in the beginning, but as we added more and more teams to our project to build on different parts of our data graph, we started to seeing some problems with this approach. While for the front end, it's amazing. Like we have this one monolith, you can pick and choose whatever you want. It can make problems in your back end where you suddenly are standing on each other's foot when you deploy or change something. Think about your team wants to update the .NET Core version or wants to use a completely different technology, and the other team doesn't want to do that. So you're kind of blocking each other. And while a monolith is quite good if you want to do code changes across the graph, it kind of also limits your flexibility. So we started to see difficulties to scale our graph, and not in the way like throughput or data scaling. Like we had problems to scale our graph to add more developers to work on that thing. So we reflected a bit back then, and when you look at how GraphQL was originally adopted when it came out, it kind of was used as a gateway technology on day one, right? Because people were, or exactly front-end engineers, were taking GraphQL.js, and they would spin up a server and basically wrap the REST endpoints that their backend engineers provided. Because their backend engineers were not immediately ready to jump ships to GraphQL, so the front-end engineers kind of created a BFF with GraphQL to wrap the REST endpoints that were existing into GraphQL. And if you look at that architecture, we already see that we still have this unified API that we want to have, where we can shape how our business model should look like. But we also have like downstream services where each team could work on. And that is actually already distributed GraphQL if you think of it in a simple case, right? We have a GraphQL gateway, and then we have downstream services with whatever technology you want to have there. As GraphQL evolved, also the technique around evolved this. So initially we introduced, or the GraphQL ecosystem introduced something called schema stitching, and everybody did that a bit differently. So what is schema stitching? Basically formalizing GraphQL as a gateway where we have downstream GraphQL services that we stitch together into one graph. This way, each of our teams that cares about a certain domain aspect or organizational aspect in our code can own a part of their graph. But it still had problems here, right? Because like in schema stitching as well in this initial primitive approach, we have the problem that you kind of have still this gateway as a monolith where you have to kind of negotiate. If one person is doing a change to their downstream services, they always have to also do a change to the gateway, right? To the composite schema here. So schema stitching, when we talk about time frame a bit here, so GraphQL came out 2016. In 2017, we had these new approaches of schema stitching. And there were tons of other things coming out after that, like Apollo Federation. There was an approach from Atlassian. We, with Hot Chocolate, had our own schema stitching version. And the problem here was there is no open standard. And there was also no interoperability. If you choose one approach, you couldn't go with tools from the other company. And that kind of had this not so nice effect that you kind of was locked into one of these vendors. So the Guild and Chili Cream, the Guild is also a company in the GraphQL ecosystem, and Chili Cream is my company. We started working towards an open standard under the GraphQL Foundation. And as we started our journey there were companies like IBM, AWS, Hasura quickly latching on to create a new standard in the GraphQL ecosystem. And that is called the Composite Schema Specification. The prototype was originally called Fusion, but now the more formal name is the Composite Schema Spec. And if you're interested in the specification process, then you can also join these meetings. It's now under the GraphQL Foundation, and there's this Composite Schema Specification repository. So if you're interested, you can join that effort. So with this approach, we want to embrace GraphQL. We didn't want to take over these kind of vendor-locked solutions where you even maybe broke a bit the GraphQL contract. We really want to embrace GraphQL as is. And we want to allow any schema or any GraphQL server to be part of such a distributed schema. And we also want to support and use all the GraphQL patterns. What are GraphQL patterns? Typically, we refer to the enterprise GraphQL patterns like the relay server patterns, like the node pattern, or the cursor-based pagination patterns and whatnot. So with this new approach, and I show you some code from the first prototypes that we have, formalizes a bit the naming scheme here. So when we talk about this part in the middle, we are actually talking about the composite schema. And the downstream services are source schemas. Behind these source schemas can be still your microservices or whatnot, depending on how complex you want to build that. The idea behind that is that each team can own a part of the graph and can drive changes from the source schemas to the composite schema without reloading or redeploying the gateway, right? This approach is meant to be collaborative. So you are working with other teams on this graph, and we want to basically unblock you. And collaborative means really that you and your teammates have an understanding about what certain types mean in your schema, like what is a user, what is a review, or what is a product, right? You have a shared understanding of your business model. And it's composable. And composable means that types can exist across graphs. Like you can have the same type in different versions existing on different subgraphs. For instance, in this example, we have a user type that lives on the accounts service. And on the accounts service, this user type has maybe an ID, name, birthday, username. But it also lives on the review service, and on the review service, the user is the same user, but has different properties. We have some overlap here, like ID and name, but we also have a field reviews, because this user represents on the review service the author of some reviews. So this user maybe has the reviews collection of the reviews he or she wrote. When the GraphQL Composite schema specification composes the composite schema. It can merge these types because we know semantically they are the same. That means we can kind of integrate them. And we have now overlapping data, and we'll show you in the demo actually what that can do in the query planning process. And we have data that is specific to one or the other subgraph, like birth date and username only lives on accounts and reviews only lives on reviews. This approach is evolvable, and what we mean with that is that it's evolvable by each team. So each team can evolve the schema in isolation. So the accounts team, for instance, can introduce a new field to their type without talking to the reviews team, right? They can just add that because it's in their domain. And then it will just merge. The moment they publish their source schema, the schema will merge and the new field will be available. So there's no blocking anymore or no coordination for deployment. But if the reviews team, for instance, introduces a new field that we already introduced with a different type, so there's a mismatch, in this instance, we get a compile error right when we are building our source schema. So you have compile time security that you're not breaking the composed graph. This approach is explicit, and that means we are not guessing what you mean. We are looking at the types, it's semantics, and at annotations. Let's have a look at that. So I prepared a little demo here. And in this demo, I have basically a web shop API. We have here our gateway. And let's get that out of the way and let's just start our gateway. This gateway is not yet configured. It's configured. The configuration is basically the schema of each subgraph or of each source schema. So we have here 4 source schemas. There's an accounts schema here that's a node service. And this node service has a schema that cares just about users. We have here user with display name, birth date, and a couple of other types, right? So the first thing to get this schema into our gateway is to compose it. So we go to our console and then we say Fusion, compose. We point to the gateway. And we also point to the subgraph or the source schema that we want to compose into our gateway. So I'm running that against the accounts subgraph here. And then I already can go to our gateway. As I said, it's hot reload, so we can just go here. Let me just get that away here. Okay. And then we can have a look at our schema. And then we can see that all the types that I had in accounts are now available through my gateway. Maybe you have noticed that I didn't even start my subgraph here. So this is still not running, my node server, but I already have on my gateway all the information about the schema. I could even run it because it could happen that sometimes your subgraph maybe is not available anymore. So the gateway has to cope with that, right? So we can go here to the users and then maybe select the nodes. And from the nodes, we take the name, so the username. And what happens here is basically that the thing is not there. And we do this thing that we would do in GraphQL and would deliver a partial result. At this point, there's no point to a partial result because the whole server is down. But if some of your subgraphs at some point in time are offline, then we just compose partial results as allowed by the GraphQL specification, right? And then your front end can decide if it wants to deal with partial results or just rejects them. Okay, let's start actually the downstream service here. And then let's go back to our gateway. We run that, and then the data is just there. Okay, that's not very impressive, but it will become more exciting as we go. But when we look at this, we cannot really see what's happening here. And into Banana Cakepop is this GraphQL IDE here. We have built in a query plan visualizer. So we can say, tell me what's actually happening in this request. And then we can have a look what is happening here? In this instance, we are fetching from the account subgraph some data, and then we compose it. We can also look at the textual representation here. You can see that the initial request is coming in, and then we have a sequence in which we resolve the data, in this case, from the account subgraph, right? Okay, because we just have one subgraph integrated here, it's not very exciting. Let's do a bit more. So let's, for instance, start the product subgraph. It's also a node server. And I'm gonna go ahead and start all of them. And then we can start composing them into our graph. So the first thing I want to compose into that is actually the reviews service. That's the one we also had in the slides. So I'm going here and say Fusion compose reviews into my gateway. So when I go back to my gateway and refresh my schema here, I can see that I have now more types. So I have now a mutation type here, subscription type. And also if I look at my root fields here, I have products, I have reviews. I can dive from the user now here into the reviews. So the types are now integrated from these two services. And from the reviews, I could go again to the user. And I also have here a hint to the product. Product at the moment just has an ID, but I could query that. So let's maybe get the reviews of this user. And the reviews. And then we want the body of the review. Run that. And have a look at the query plan. And what is surprising is that we get all the data now from reviews. Because we know about overlaps. In my presentation, I had in both services, ID and name in both services. These are overlapping data. And the composite schema specification takes advantage of this overlapping data and can rewrite the query planner to only get the data from one hop, right? You want to reduce the request that you're doing to your downstream services. So what we are doing is basically figuring out that we can get all the data that is requested here actually from the reviews graph instead of the accounts graph. The moment I'm asking here, for instance, for the birth date, some data that is only available on the accounts subgraph, we are rewriting this thing here. You can see now we are getting still the biggest blob of data from the reviews graph. And then we are going here to the accounts graph. And you can see this graph will export basically the user ID. We are feeding that in as a batch into the next request. So if we look into the JSON here, you can see that this is the request we sent to reviews now. We are overfetching the user ID because we didn't request that here. And then we are feeding that into the next request as a batch. You can see we are feeding here an array of user IDs into the next request and get batched out here the birth date. Then we are composing the graph and you still have the standard GraphQL result here now with the birth date and then the reviews here. Okay, let's put some more stuff in there to make it a bit more interesting. So for instance, we can go now to the products catalog because we have these reviews about a product by a user. And now we are integrating here the products catalog. And then we can have a look at our schema again. So when we go now in our query type here, I can go in users, user, go through reviews. And now we have products and you have all the data about product, like the picture of the product. We have the name of the product. We have a weight of the product. We have a dimension. So we have a lot more information about the product. So we could, for instance, now query here the product. The product name, for instance, is interesting to us. Rerun that. And then you can see the query planner has adapted to this. We now have here this initial fetch still to reviews, but then we parallelize and fetch two batches for all the products in our list. and all the accounts in our list from these other two subgraphs. So the query plan evolves and makes sure that the data is always resolved in the most efficient way from your downstream services. Okay, so let's do one more thing, and then we can have a look at some other aspects of this. So we have here also a service that is called shipping, and shipping just has an algorithm to estimate the shipping time that a product needs if you want to order it. So we're going to just compose that naively. As far as we went now, I didn't do anything to my subgraphs. I just said, okay, this is a subgraph, composite, and the composition figured everything out automatically. So when we go now to shipping here, and I compose that in and refresh that, then you can see that the shipping graph that we integrated now into our product, there's the delivery estimate. So when this product would be available for shipping, a maximum time and a minimum time. But you can see this has arguments. So in order to calculate the shipping estimate, we actually need a size and weight. And we need a zip code for this product. Actually, when we look here at the product, from the product service, we already have the information in the dimensions object. But this lives on a different graph. So what we can do now is actually give our composition a bit of metadata to be able to resolve this data automatically and not expose this as arguments here. So what I do is I go here to my shippings subgraph, and I can add another GraphQL document. That's the schema extensions.graphql. And then I could say I want to extend the product. And by extending the product, that's standard GraphQL syntax. And let me actually zoom in. That is standard GraphQL syntax here, where I say I want to extend the product to enrich it with some metadata. And then I could say I want to require the size here. And I want to require the weight here. And I'm specifying that this value comes actually from dimension and then from the size property. That is standard GraphQL syntax. It's the selection syntax that we anyway have in GraphQL that is relatively to the product. If I had a typo in here, we would get a build error. So there is no magic string, it's compiled. So when I go now to my composition here, I can say Fusion Compose again. So while I'm composing here, my gateway never restarts, because what we do in the gateway when a new schema comes in is actually all the requests that are running at the moment will finish executing against the old schema while we are slowly phasing in a new schema version. So now let's go quickly to our gateway here. We refresh that. If I look at my product here, then you can see we don't have any arguments anymore to provide this data, because the gateway now resolves this data internally. So if I run here my query and want to get the delivery estimate, I have to provide the zip code, but I no longer have to provide any other information. So when I run that, you can see that our query plan gets bigger. So we have here this parallel, we resolve still the products and the accounts. But then in the product here, you can see we are exporting. So we are getting in the product ID, but we are exporting into the query plan the product dimension, size, and weight. And that is consumed by the shipping subgraph to produce the last piece of information. And if we look at that, we can see here that we are producing for this user has a review, and the review in this case produces the delivery estimate here, and the data is completely resolved internally. Okay, so let's do one more aspect of that. So while I composed there, like I don't have to care about transport. That is what the gateway actually does for me. So we figure out what each subgraph speaks? Is it gRPC? Is it standard GraphQL over HTTP? Is it WebSockets or whatever? And we also recognize each GraphQL feature. Like at the moment, we just did queries, right? But you can already see that we also support subscriptions here, and that is real-time querying on my downstream GraphQL servers, and we are composing these query plans in real time. That means, let me quickly go to my demo here. I could open another Banana Cakepop instance. Is that already on the right one? No. Quickly sign into, no, not this one. Yeah. Actually, let me just grab this guy here. Okay. So I'm just grabbing the URL to my gateway, pasting that in. I don't care. And then we can just do a subscription here. So I will subscribe to the reviews of my gateway. And I can run that, and what you can see is nothing, because like we subscribed. A subscription basically is we subscribe to a message bus, and now we are waiting for something to happen. In this case, we are waiting for a review to be written. And just to show you, like in this instance, I'm just going here for body and stars, but I also could get the author and all the data that we have on the standard queries, right? So this is waiting now for something to happen. So let me just quickly open here a mutation and hope this works. And now I can create a new review here. And in this case, the product ID is wrong. Oh, which one? Okay, let me quickly fix that. So we need some correct IDs for the user and for the product. Okay, so I'm grabbing this user ID here as an author. So we are writing this for this review in the context of this author. And then we are also grabbing here the product ID. Sorry. And we just paste that in. Okay, let's rearrange that. And we run that, and you can see it's in real time. So also real-time data just composes in this subgraph. So if one team decides to have a new real-time API, we could just go here, for instance, into our shipping graph, and we could say, okay, we want to now have a new GraphQL subscription. This is my subgraph. So I could just introduce here a standard class, like subscription class. Okay, this is my subscription, just subscribe subscription type. And then we could, like a subscription typically has a stream. So I could just have here an async enumerable as a stream. And that is a string on foo. Let's make it async. And then we would do maybe task.wait, just to have some delay in there. Delay, sorry. Maybe 1 second, or let's wait 2 seconds. Then we return here a string, like a yield, return. And we could repeat that 1, 2. So this would raise 3 events. Is that good? No, this needs to be static. And then we have the actual event. This is our stream. And then we have the actual event hook, static, and this returns just the string. on foo. Okay, and this gets an event message. It's a bit unscripted here. This is the payload. And then we just return, in this case, the payload. This is our standard resolver. Typically, you have you do other stuff like loading something from the database or whatever. This is our subscribe resolver, and we subscribe with our stream. So this is how we subscribe to the data. So I did this change just to my shipping subgraph. And now I can go to my shipping subgraph, just restart it maybe. So in order to get the schema dumped, in Hot Chocolate we have like this schema export where we can output the schema. So I run that. And then we should have here a subscription type. And you can see here's our onFoo event. We can now run our subgraph again. Then compose this thing. And then we have the change in our gateway and could call that. Like the cycle to get that in your graph is very quickly. Like you can really drive change from your subgraphs to the overall gateway. So if I refresh that, I have a new schema, and then I can just ask for the subscription that I have here on foo, run that, and then I should get 3 events. This is the first, second, and then the third is coming. And then this is a finite subscription, so it will unsubscribe and it's done. Just to show you a bit the cycle from going from your subgraph to the composite schema is very quickly, like the turnaround is very quickly, just basically publish your subgraph and then the overall schema is being composed. Okay, let's talk a bit about the key things that we have in the composite schema specification. Like the configuration is decentralized, and what that means is your subgraph is the configuration. And that's actually what I did there. I changed something in the subgraph and it changed the overall graph. And that really unblocks your teams. They can ship in isolation. They can work in isolation without coordinating every change. Like you are coordinating, because it's collaborative, what certain types mean, but in your domain you can just do. It's a declarative approach, and that means like if we cannot infer something from your types, you just annotate it with these directives that we use, like the require directive. You basically give us declarative information about what things mean in your graph. We do composition on build. That's what I do on the console. Typically, that runs in your CI/CD pipeline. So the moment you ship in your CI/CD pipeline, you would run this Fusion compose command, which will publish that to your gateway. And publishing it to your gateway, what does it mean? It could be a blob storage or whatever where your gateway listens to. The standard that we are working on, the composite schema standard, is open. It's developed under the GraphQL Foundation, and the GraphQL Foundation is part of the Linux Foundation. So it makes sure that this standard is published under a permissible license, and everybody can implement it on their own. So it's available across platforms, and we are working with companies like AWS to get it more widely adopted. So source schemas in this approach can be valid on their own. As I said, we are embracing all GraphQL features and best practices. And like the last thing is overlapping data. Overlapping data can be used to improve performance. That's the first thing I showed, right? After we introduced this review subgraph, we were still just fetching from one graph because we recognized there was overlapping data and we could reduce the impact to your downstream systems. So let's talk about query planning a bit. So query planning, we looked at that, like we looked at the shapes there. What we do in Hot Chocolate is essentially getting you a quick query plan immediately. And we are using a cheap algorithm to do that. Basically, we're figuring out the biggest chunk that we can get from somewhere, and then we're getting smaller and smaller. We are doing also, after that, something called profile-guided optimizations. So we are trying to figure out a faster query plan. And then we are issuing this query plan to 20% of your machines. If we see that the OpenTelemetry feedback implies that this is not good or is not faster, then we are dropping this query plan. If it's good, we are expanding it to 100% of your machines. So your query plan can become faster over time. This is all driven by OpenTelemetry. Let me show you that a bit. Like Banana Cake Pop has like a whole suite to it. This is, for instance, our gateway overview, where you can see, for instance, at this point, we have here 3 clients, a web client, a mobile client, and some other clients that are not doing so much. But you can see here's my gateway, and I can also see my subgraphs here. I could drill into, for instance, the review subgraph here, have an overview at what is happening. This is available at development time. We are integrating that at the moment with Aspire, so you get also the real-time telemetry from Aspire directly in that dashboard. Our dashboard is a bit nicer than the Aspire dashboard, but the data is then coming in this instance from the Aspire instance, so you get immediately your data, but more optimized of GraphQL and the gateway request. We can see, for instance, this is the downstream request that we get to this subgraph. And we are doing, for instance, here 2 database requests. What we can see also in here, this is a subgraph. It uses data loader. So we can also see that the data is being batched. So that's why we have this gap here. First, we resolve basically the main data, and then we are batching these 4 resolvers that we have here in one go to the database before we transform the request. You get all these deep insights into how your subgraph is working. And you can also have that on the overall graph. Like I could go also into the distributed view here and get insights, for instance, into my gateway. For instance, here we are going into the gateway. Then you see down here we're going into the subgraph. And in the subgraph, we're going in the database, and then we're going in another GraphQL server, so you can also see that in a distributed way. And that makes it very, very simple to optimize this thing and to grow your solution with your peers. What you also get is, like I talked about, deployments, like the thing where you ship a new subgraph. You can see that in real time, that are the real-time deployments that come in. The Fusion will make sure that you don't break the overall graph. And that we do in composition. For instance, here the deployment failed. We could also see what actually failed there by, I have to go a bit back here. There you can see, for instance, there was a breaking change. So what we checked there is we compiled the overall composite schema, and then we figured out it would break one of your clients. So we know which queries actually each of your clients uses. And that is because in GraphQL we compile basically the clients against the backend. And then we also know which version of which client uses actually which field of your graph. So when you do a change to that, we will stop you from doing that and saying, okay, this field's orders, for instance, that's a breaking change that breaks these 2 or 3 client versions that you have out there. First, make sure that these clients don't send requests to your GraphQL server anymore, like deprecate them, and then we allow you to do the change, or you force this through. So you will never break your clients. Like when people talk about GraphQL doesn't need versioning, it's because of these kinds of tooling that we have in the GraphQL space, where we make sure that you really never break a client and you know which client actually uses what kind of data from your overall graph. And then you can do some educated decisions based on this data. Okay, with this, I'm actually almost through. Yeah, this we had. Like, as I said, we're working with a couple of other companies that are also early adopter, like AWS. You can use Fusion and the composite schema specification with AppSync, for instance. There's a blog post on AWS. So if you're on AWS, you can work with that if you're using AppSync. We are also working with Hasura on that. If you're using Hasura, you can also combine that. With that, I'm basically done. If you want to follow me or hit me up on Twitter or Slack, you can do that. And I'm open for questions. We have 10 more minutes. So if you have questions, go ahead. So we're using it at one of the biggest retailers in Switzerland. But the specification is at stage 0. So you can, like, the implementation is valid, but the specification changes over the next year. I think the composite schema specification as is will be stable in around 12 months. But if you don't mind changing, like, what that means is basically the directives and composition rules may change. But yeah, you can use it already in production if you don't mind to doing a change.
And what takes you like, and what's the deployment kind of model like in that?
You mean like from a CI/CD standpoint?
Yeah. So if I wanted to implement it tomorrow,
yeah.
What am I looking at? What am I deploying?
Yeah. So let me show you maybe. I'm working at the moment on a demo with Aspire. So you can basically use an Aspire thing. I'm at the moment reworking like David Fowler's example of the eShop. I don't know if anybody saw that. Maybe in 3-4 days, I will have it done. But this is basically the approach. So what the Fusion Gateway is basically one code file. It's a ASP.NET Core server. It has one package, that the Hot Chocolate Fusion package. And the only setup you have here is Fusion Gateway server. In this instance, we have the configure from cloud because it runs in Aspire. So everything is basically configured in your Aspire host. I don't know if you guys already are familiar with Aspire, but this is how you set basically the orchestration between the gateway up. In this case, for instance, I set, so I'm still migrating here. I have one subgraph that's a catalog API that they have there, and then I integrated that with my gateway, like with reference to the catalog API. This is the way I configured that here. And that is also all build time. So when I build this solution, when I build the app host here, it actually composes. So it's very easy to deploy it with Aspire. You basically set that up in your CI/CD pipeline. The moment you compile the project, you know that it composes, and then you can deploy it with the Aspire standards that you have here. You don't have to use Aspire. You could also just deploy it as a simple container. So the gateway could also just be a simple container. The cool thing really with Aspire is the telemetry insights that you get at development, and all the integrations that we do with Banana Cake Pop in it. And so it's a quite nice experience. But you could also just say, I'm using this gateway here, and we have, like there is, for instance, if I go into the gateway here, you could also say configure from a file, and then you have a blob storage there, and that's where you put your composition output. So the composition output, just let me show you. So what I did here is basically a local composition. So when I run this composition tool, what it does here is basically dump this gateway FGP. That here is basically a glorified zip. So I could just, that's the composition output. Let me just go reveal in Finder. Does this come? Yeah. So I could unzip that, and then you can see there's basically a GraphQL schema in there. with all the composition rules. That is actually the public exposed GraphQL schema. What we use to run the gateway and run the query planning is this Fusion GraphQL, which is a heavily annotated GraphQL schema where you actually can see what is happening here. So if I call node, then I have a resolver to accounts. Like these are all the metadata that I have to the various subgraphs, or this variable declaration here tells me that I need to get some data that I need to feed into the subgraphs. So this is a heavily annotated schema, and that is being produced. So you can use a blob storage to configure it if you don't want to use Aspire or whatnot. Could also be just locally on-prem, just dump it on the file system. Yeah.
In terms of like, so in terms of linking the various nodes, so you showed the example of the reviews to product, and so the internal like definition of that is that you've when you're storing the review, you've got a product ID field, but then you've got the type, which is product, and the subfield, which is ID.
Yeah.
So how would you link?
So how you link is basically you have these partial types. For instance, if you have somewhere where you just have a user ID, in your GraphQL schema you would have a user which has just the ID. You don't have to have the user object in your C#, but you have to have the user in your GraphQL. Right. So you have to tell us this ID doesn't just mean user ID, it's actually from the type user. Okay. So the linking is always that you have types. And then we see, okay, this is the same type, like user and user, we can squash it. So if I wanted to introduce, for instance, let's have a look. So when I am here in reviews, I just have it in a type here. I have product, but product actually just has an ID, right? And a reviews on it, because that is what the review service knows about the product service. So we have a notion of product in this subgraph, but we don't know anything else about the product. We just have the ID, and we know that these kinds of reviews, this is how I can get reviews for products. So I model that in this GraphQL type. This type doesn't need to exist in your database. It's just kind of a stub type where I say the product in my subgraph can have reviews, and then we integrate that with the overall graph. So it's very simple to do that. Other questions?
Is what you've done with Fusion a sort of competitor to, like, I've seen Mesh before? Is it the same kind of thing?
No, so we are working with the Guild on it, and also Apollo is working on it. Mm-hmm. As I said, this is not like we putting a specification on GitHub. It's under the GraphQL Foundation, so it's under the standard body that is actually building the GraphQL specification. So when you go here to this is in the GraphQL organization. And we are working there, like, for instance, like Martin here is from Apollo. It's also like we are working in a collaborative approach with all the other GraphQL companies out there to build an open standard that everybody can adopt. And that means for you as a user, you can take that and then you can mix also the tooling. If you, for instance, like Banana Cake Pop from us, you can use that, and then you maybe like Mesh. There's already a pull request that integrates Fusion in Mesh. And then you could combine these tools and they just work out of the box together. That's the idea that we have. At the moment, you have Apollo Federation, for instance, you have schema stitching, you have, I forgot the thing that Atlassian did, but they are all kind of vendor-locked solutions. And that means you're locked into Apollo Studio, into whatever tooling everybody has. And the idea is to open that up and have a standard core specification that still makes it possible for each of the vendors to have like maybe a very good solution for authorization that is not part of the standard, but that might be the reason why you go for Apollo or for the Guild. But the core specification, the core tooling will be open source.
Cool. Thank you.
More questions? We have time. 4 more minutes. Otherwise, you can also hit me up. I'm still today and tomorrow at the conference. So if you want to have a chat about GraphQL, you are invited to come over. Awesome. Thank you.